to describe equilibrium in autarky. And all those complicated derivations and time-consuming derivations that we were doing all over the last 15 videos will actually pay off a lot. Because look, now it turns out that we can graphically describe autarky equilibrium very easily. Because, look, we are going to do it in a space with numbers of goods, where here we have food, and here we have manufacturers. Okay, so how will this autarky equilibrium look? Okay, for now, we're just going to start with one country so you can see generally how to draw it and how to okay, so we start with production possibility frontier. Okay, now the second thing we need to have is that we need to have a price ratio, right? Ratio of price of manufacturers to price of food. Why do we need it? Well, we need it because only with this ratio we will be able to choose a point on the production possibility frontier that will tell us how much manufacturers and how much food is produced. Okay, so let's just say that this is going to be this point, and here is our price ratio line. So this one is given, of course, as usual, but as PM over PF. And of course, this is production possibility frontier. Okay, but now that we have the point, this point of production, we can go even further, because look, we have this line, and this line is actually showing is also needed to determine at which indifference curve we are. And look, because we said we've got homothetic preferences, then individual indifference curves could be aggregated to one big indifference curve that we're going to call welfare for now. And look, this is giving us our full equilibrium. So, this is how graphically we can describe equilibrium in neoclassical model when we have autarky, when we just have one country. And okay, look, what we've got here, of course, the blue line is our income line, right? Because we can take it from the customer's choice problem. And this income line has a slope, as we said, equal to, well, negative PM over PF. We usually do not write this minus, but of course, technically speaking, this is how it should be written. Now, if we've got welfare line, what is the slope of the welfare line? What is the slope of the welfare line? Well, the slope of the welfare line is marginal rate of substitution. And look, this is why I deleted this minus. Because remember, when we had marginal rate of substitution, it had minus up front, right? this, like a marginal rate of substitution is created by imposing absolute value, because this would be negative, of course, because if I'm having one more unit of one good, then I need to decrease the number of units of some other good. So of course I will always have negative outcome. But of course, to compare them, we just can take absolute values. And finally, what is the slope of PPF, so our production possibility frontier? Well, the slope is equal to marginal rate of transformation. Okay, so look, what we are getting out of this is that on one hand, at this point, we have production equilibrium. So here we will have autarky production. But this point, when we look at this from the perspective of production possibility frontier, but when we look from the welfare line, so from the indifference curve, we see that this is also autarky consumption. Okay, so look, we know that the same point is autarky production, autarky consumption. So we know that this point is our equilibrium. So what should be the equilibrium condition? Well, it's very simple. Marginal rate of transformation, we're going to use subscript AU to denote autarky, must be equal to the price ratio in autarky, and this must be also equal to marginal rate of substitution in autarky. Okay, and look, this fundamental condition is giving us the equilibrium in neoclassical model of trade. We will expand it a little bit further, but let me just elaborate on some consequences of what we have found over here. Okay, but so before we actually calculated that the price of manufacturers is equal to gamma m times rent to the power alpha m times wage to the power 1 minus alpha m, where gamma m was defined as alpha m to the power negative alpha m times 1 minus alpha m to the power negative 1 minus alpha m. And look, by the same token, price of food is given by gamma f times r to the power alpha f times w to the power 1 minus alpha f gamma, where gamma f is alpha f to the power negative alpha f times 1 minus alpha m to the power negative 1 minus alpha f. Okay, so what we have in our equilibrium condition is the ratio of these prices. So let's now calculate the ratio of price of manufacturers to price of food. Okay, so we get that this is gamma m over gamma f. Okay, this we don't need to actually simplify those. We will leave it like this, but we need to simplify the rest. Look, we're getting here that this is r to the power alpha m w to the power 1 minus alpha m and r to the power alpha f w to the power 1 minus alpha f. And look, what I want to do right now is to have w on the top while I want to have r in the bottom. Okay, so this is equal to gamma m over gamma f. And now, let's start with r. Look, if I want to have bring r down, I need to just impose minus up front, right? So I will have this is r to the power alpha f minus alpha m. Right? Now, over here, I want to bring this up. So I will be subtracting, right? And so I'm going to have w to the power 1 minus alpha m minus 1 plus, right? Because minus and minus gives us plus alpha f. Okay, so what do we get? What do we get out of this? We get that this is lambda m, gamma f over. Those two cancel each other out, so we get that this is w to the power alpha f minus alpha m over r to the power alpha f minus alpha m, which we can easily transform to alpha gamma m over gamma f times w over r to the power, and look, I'm going to take minus out of this expression, so they're going to change the order. We're going to have to the power negative alpha m minus alpha f. We like to have it in this way because we know that then this is a positive fraction and we have minus up front. Okay, so look, in other words, now we can say that price ratio in autarky can be expressed as the sole function of wage and rent. Gamma m over gamma f times wage over rent to the power negative alpha m minus alpha f. Okay, and this result will prove very important to us because it will allow us to connect changes in capital, wages, and capital to labor ratio, wage to rent ratio, and ratio of the two prices. Okay, look, the next condition that I'm going to use is a little bit more complicated. This is the condition that I've been telling you about in the previous video. Look, we need to, if I will take demand for manufacturers in this economy and I'm going to equalize it with supply of manufacturers, this is what I'm going to get. I'm going to get that wage over rent in autarky is equal to gamma in autarky times capital to labor ratio. And in this scenario, this gamma in autarky is equal to 1 minus alpha f, minus delta m. Remember, delta m is the parameter that tells us what is the share of spending of the customers on manufacturing. That we of course take from the utility function. Okay, and this is divided by alpha f minus plus delta m times alpha m minus alpha f. Okay. going to provide a detailed derivation in the next video because this is a very time consuming. What I just wanna tell you is that look, this relationship takes all the information from the entire model. Actually, because look, here we have parameters from the production function as well as parameters from the utility function. The only thing missing, of course, are prices, but in order to get from capital to labor ratio to prices, well, all I need to do is to substitute this over here. And this is what I'm going to do in a second. Just let's think about this for a second. Look, wage is a positive number, rent is a positive number, capital, positive number, labor, positive number. So look, this tells us that this must be positive, this must be positive. So this expression clearly must be positive as well. Even if we do not see it right away, and again, showing this would require a lot of algebra. If you want, you can do it on your own as an exercise. Oh, of course, here we should have by definition. We can clearly see that this must be a positive number. And look, now if I'm going to differentiate wage to rent ratio with capital to labor ratio, I'm going to get this is equal to gamma in autarky, and this must be positive, right? So look, out of this, we are getting a very simple relationship that if capital to labor ratio in the economy is going up, which, let's just say, look, the easiest way to imagine it is labor stays at the same level, we've got more capital. Look, if we've got more capital, rent should go down. If rent goes down, when wage stays at the same level, wage to rent ratio should go up because we divide the same wage by lower rent. Okay, it makes perfect sense. But let's get one step further. Now, let me just substitute our result inside the price of manufacture to price of food ratio. Okay, so I'm just taking this and substituting it over here, and I'm getting that this is gamma m over gamma f times gamma to the power negative 1 alpha m minus alpha f. And here I have k over l to the power negative alpha m minus alpha f. Okay, so what will happen? Now if capital to labor ratio is going to go up, and what is going to happen into the prices of manufacturing, ratio of prices of manufacturing to prices of food. Okay, look, again, we can find this very easily just by calculating derivative dPmPf k over L, right? Look, this expression goes up front, so we've got minus alpha n minus alpha f. Then we rewrite everything else Okay, and now look, capital to labor ratio is positive. If we take it to any power, this is still positive. Look, all those numbers over here are some positive fractions, as we discussed previously. And look, we also know that this number must be positive on the assumption that production of manufacturing is more capital intensive than production of food, and consequently we've got 3 positive numbers and minus up front. This of course must be negative. And look, now what we've actually obtained is relationship between capital to labor ratio and the price ratio. So look, how can we? So what is going to happen in this economy if capital to labor ratio is going to go up? Well, first thing we will see is something that we discussed previously, right? Now we know that this the consequence of the increase in capital to labor ratio is going to be an increase in wage to rent ratio. And look, now we actually have the entire story and we can see what is going to happen. Look, if wage, let's start like we said before. Look, in the economy, we have constant labor, a constant level of labor. The amount of capital increases. So capital to labor ratio increases. Look, as a consequence, wage to rent ratio is going to go up because rent is falling. And now look, if we have a situation in which rent is falling, it means that rent is a payment for capital services. And look, which of the two goods uses capital services intensively? Well, manufacturers. So look, if this is going down, we expect that the price of manufacturers should go down by more than price of food. Why? Because food uses this factor of production less intensively than, of course, production of manufacturers. So we get that in this economy, increasing capital to labor ratio should be associated with price of manufacturers to price of food ratio drop. Okay, and look, actually, this relationship, you might think, like, why do we need it, right? Like, why do we need to actually state this relationship in the context of what we just said, equilibrium autarky? Okay, look, this becomes important when we want to have two autarkies compared. Okay, and let me show you now how can we compare those two autarkies. Again, look, we go back to our example that we have two countries. One country is going to be Austria. Austria is a country that is relatively capital abundant, while second country, Bolivia, is a country that is relatively labor abundant. Okay, so let's write it like this. We know that capital to labor ratio in Austria is bigger than capital to labor ratio in Bolivia. And what should this imply in the context of prices in those two countries? Well, this is why we actually needed this relationship. And here we have PM over PF. And B. Okay, so if the higher capital to labor ratio, the lower price of manufacturing to price of food ratio. So here we should have a situation like that, right? We expect that because Bolivia is labor abundant, the price of food is going to be relatively lower than in Austria, and on the other hand, the price of manufacturing in Austria, which is capital abundant, should be higher, and as a result, we see that this ratio will be lower in Austria than it is in Bolivia, right? Okay, so now, look, this is one important thing. I'm going to show you now production possibility frontiers for Austria and Bolivia. But of course, look, if we can, and I hope that this is going to be intuitionally obvious to you that if Austria is capital abundant, it will have a production possibility frontier like that. Well, if Bolivia is labor abundant, it will have production possibility frontier like that. Okay, I'm going to denote this one A and this one B. Okay, again, I'm not 100% sure I'm going to make a perfect graph, but hopefully I will. Okay, look, but remember, this works in our hypothetical economies, because look, if one economy is bigger than the other, we can easily expect the production possibility frontier of one country, like if we would compare the United States with Austria and Bolivia, the production possibility frontier would be not even here, but somewhere over here, very, very far away. And consequently, of course, the graphs would not look that well. So here we take this assumption that those countries are more or less of similar sizes, so we can actually compare them. Okay. And now, look. The key thing for us is now going to be setting up level of production of two goods in two countries using price ratios. Okay, so what do we know? That this number, remember, we should say in absolute value because it's going to be negatively sloped. So absolute values over here, this absolute value should be lower than this absolute value. Maybe, I'm going to do it with different colors so you can see it actually better. Okay. And look, because those are negative values, when we talk about their absolute values, of course one is going to be steeper than the other. Which one is going to be steeper? Well, this one. Why? Because absolute value of it is bigger. So it needs to be going down faster than this one. Right? So look, over here we can see that, for example, that the PM, so the income line, PF line for Bolivia, is very steep. Now, it's steeper than in case of Austria. And look, here, because it's a lower value, it needs to be flat. So let's put it like this. Okay, it's it's becoming too, how to say, too curvy, and this line, of course, should be a straight line. Okay, now it's almost perfect. So this is PM to PF ratio for Austria. Okay, and look, now we can draw finally the utility curves or welfare curves for those two countries. Okay, so look, again, the exact shape of the utility curves would in this case also distinguish which country is better off. But I hope we can see that we can draw them, for example, like this. Okay, here we have Bolivian utility curve, the yellow one. Okay, I'm going to call it UB. And now, okay, which color I haven't used? Maybe green. Now I should draw the one that is exactly parallel to this one. I'm not sure I'm going to be able to do it. But why do they need to be parallel? Look, they need to be parallel because we've got homothetic preferences. So they need to be parallel to one another. But of course, for two different countries, they can be in different positions. Okay, and here we have UA. Okay, and look, now we have established equilibrium points for our two countries. Look, here we have equilibrium in Austria. And here we have equilibrium in Bolivia. What can we look? This graph basically summarizes autarky in two countries, right? Because look, what do we see over here? On one hand, we see that that Austria is more capital abundant, relatively more capital abundant, while Bolivia is more labor abundant, and because of that, Bolivia is able to produce more food, while Austria is able to produce more manufactures. Then, we know that as a consequence of the equilibrium conditions within this economy, we can say something about their price ratios. We've established the direction of price ratios. And because we have established this direction of price ratios, we can choose more or less the points that should be chosen on each of these production possibility frontiers. And now, knowing those points, we can fit a tangent in difference curves or welfare curves. And as a result, we are able to compare which country is better off. In this case, is Austria. But look, this is a hypothetical example. Okay, so look, now we know everything we need to know about autarky equilibrium. Look, in the next video. In two countries, right? In the next video, what I'm going to do, I'm going to demonstrate the proof of this result that we've got over here. Actually, this one. I'm going to show you the only one condition we haven't done. So, supply equals demand. Because this is one thing we haven't done in this economy. And then, knowing all that we know, we are just one tiny step away from introducing international trade between those two countries and seeing what happens. Okay, thank you for your attention. See you in the next video. Take care.